All right, let's dive right in, shall we? We've got this paper, Quantum Perceptrons, Kai, Their Next Generation, by Jorgo Schneeppert.
Ah, Schneeppert.
And it's all about,
Really fascinating stuff.
yeah, where AI meets quantum computing.
It is, yeah.
This is going to be a fun one, I think.
I think so, too.
Mm-hmm.
So Schneeppert's work here is really kind of bridging this gap
Yeah.
between these two seemingly separate fields, right? We've got AI, which is, already changing our lives in countless ways. And then we have this, mind-blowing potential of quantum computing.
Yeah, it feels like we're right on the edge of something really, really big.
Absolutely.
Schneeppert is saying that these quantum perceptrons
Yeah.
could unlock, a whole new level
He is.
of what AI can do.
He is. And to really grasp how revolutionary that is, I think we need to first acknowledge kind of where traditional AI hits its limits.
Okay.
Even with all the amazing advancements in deep learning, classical computers, they struggle with these massive data sets, or super complex problems.
Yeah. Like what kind of problems are we talking?
Well,
Give me an example.
imagine trying to optimize global shipping routes, right?
Oh, wow.
Or simulate how a new drug interacts with the human body at a molecular level.
Oh, right, yeah.
These are incredibly difficult tasks, even for the most powerful computers we have today.
So traditional AI is hitting a wall, basically,
Yeah.
because the problems are just too big
Exactly.
for it to handle.
And that's where quantum computing kind of swoops in.
Okay.
It leverages these kind of strange but powerful laws of quantum mechanics, like superposition and entanglement, to actually carry out computations in ways that classical computers simply can't.
Okay, now remind me about superposition again, because I always forget what that is.
So think of it this way. It's like a coin
Okay.
being both heads and tails at the same time.
Right.
So, a qubit, which is like the quantum equivalent of a bit, can exist in multiple states simultaneously. And then there's this thing called entanglement,
Right.
which is this kind of spooky connection where two particles can influence each other instantaneously no matter how far apart they are.
Oh, wow.
These principles, they give quantum computing its incredible potential.
So Schneeppert is basically saying we take these building blocks of AI, these perceptrons,
Yeah,
and we supercharge them with
exactly.
with quantum mechanics.
That's the core idea.
Okay.
So instead of bits, which are either a 0 or a 1, quantum perceptrons, they use those qubits.
Right.
What you were just talking about.
Okay.
This allows for a degree of parallel processing that's just unimaginable with classical computers.
So it's like, instead of just one little processor
Yeah.
crunching the numbers,
Yeah.
it's like this massive team
Right, exactly.
working all at the same time.
A great analogy, yeah.
Okay, got it.
And then instead of the typical activation functions you see in traditional perceptrons, which determine how they respond to input, quantum perceptrons use these things called quantum logic gates.
Okay.
So these gates, they manipulate those qubits and they perform these complex calculations leveraging, the superposition, the entanglement we were just discussing.
And Schneeppert gets pretty deep in the math here,
Oh,
right?
it does, yeah.
With linear algebra
A
and
lot of linear algebra.
tensor products, all that.
Tensor products. It's challenging stuff.
It is.
The key takeaway is that this mathematical framework really allows us to accurately model the behavior of these quantum perceptrons. It's the language we need to bridge the gap between the world of AI
Right.
and the world of quantum mechanics.
So then Schneeppert talks about different ways to actually
He does.
build these quantum perceptrons, different architectures.
Yes, he dives into two main architectures.
Okay.
Circuit-based and adiabatic models.
Okay.
So with the circuit-based models, you're essentially constructing a quantum circuit with specific gates to manipulate those qubits.
So it's like building
Just like a computer.
a custom-made quantum computer
For a specific task.
for each specific task, exactly.
Okay, and then adiabatic models are different.
They are, yeah.
How so?
Think of it this way.
Okay.
Adiabatic models, they're more about gently nudging the system into its lowest energy state, which represents the solution to your problem.
Okay.
It's a bit more of a nuanced approach,
Yeah.
but it can be very effective for certain types of calculations.
So instead of forcing a solution, you're kind of guiding it.
Exactly, precisely.
Okay.
Now, of course, none of this would be possible without the right algorithms, right?
Right.
To power these quantum perceptrons.
Of course.
And that's where things get I think, really exciting.
Yeah. I'm ready to hear about this.
Which we'll explore in the next part of our deep dive.
Okay.
Into Jorgo Schneppat's work.
All right.
We'll look at how these algorithms could potentially revolutionize entire industries. Can't wait.
It's going to be good.
All right, let's take a quick break, and we'll be back with more on quantum perceptrons.
So we've laid some groundwork here about how these quantum perceptrons actually function.
Right.
Now, I think let's dive into some of the potential applications, because this is where it gets really interesting.
Yeah, let's talk applications, because Schneppat mentions everything from logistics and finance to healthcare.
He does, yeah.
Like, where does he see the biggest impact of these quantum perceptrons?
One area he really highlights is the optimization of like incredibly complex systems.
Okay.
Picture global supply chains.
Okay.
With countless moving parts and constantly shifting variables,
right.
like weather, traffic, demand fluctuations.
It's a lot.
Right. Managing something that intricate, even with today's, most advanced AI, is a nightmare.
It sounds like a problem that's just like ready-made for a quantum solution.
Exactly, and that's what Schneppat is arguing. These quantum perceptrons, with their ability to process these massive data sets and analyze all these complex relationships, could be a complete game changer. He proposes they could optimize these systems in ways that we can barely even fathom right now.
So we're not talking about like incremental improvements here.
Yeah.
We're talking about completely different solutions.
Finding solutions that would be inconceivable with classical computing.
And it's not just logistics, right? He talks about finance as well.
Exactly. And Schneppat sees applications in finance where quantum perceptrons could analyze market trends, assess risk and optimize investment strategies with incredible accuracy.
Imagine like a quantum perceptron that's just analyzing real-time stock data.
Yeah.
And can predict like market crashes.
Exactly.
Like more accurately than any human analyst could ever.
It makes you wonder if Wall Street's already secretly working on this, right?
I was just thinking that.
But beyond that, Schneppat also points to things like traffic flow optimization in smart cities.
Oh yeah.
Imagine these quantum perceptrons are dynamically adjusting traffic signals.
Wow.
And routes in real time.
Okay.
Minimizing congestion and pollution.
So it'd be like having super intelligent traffic conductor that can see the entire city.
Exactly.
All at once.
A great analogy.
Okay.
And then there's this whole realm of big data.
Oh, yeah?
Which is, arguably one of the most exciting frontiers for these quantum perceptrons.
Because we're generating like an unbelievable amount of data every day.
An astronomical amount.
And traditional AI is already having trouble. Like
struggling to keep up.
Keeping up, with all this data.
And Schneppat argues that these quantum perceptrons could be the key to unlocking the true value of all this data, allowing us to extract these meaningful insights that would otherwise remain hidden.
Like what kind of insights? Give me some examples.
So one area he specifically mentions is healthcare.
Okay.
Imagine these quantum perceptrons sifting through massive genomic data sets to identify disease markers or personalize treatment plans, even accelerate drug discovery.
So it's like having like this medical supercomputer that can just like understand the complexities of the human body.
Precisely.
At a level that we've never seen before.
Exactly.
Right.
And it goes beyond healthcare.
Right.
Schneppat sees potential in fields like marketing.
Okay.
Where quantum perceptrons could analyze consumer behavior with incredible depth.
Wow.
Personalized recommendations.
Okay.
Create highly targeted advertising campaigns.
So it's not just about like improving existing processes. Mm-hmm. It's about
unlocking,
opening up completely new possibilities.
Entirely new possibilities, yeah.
So, we've got these quantum perceptrons that can handle massive data sets, complex problems.
Right.
But what about the algorithms?
Yes.
Like what are the algorithms?
The algorithms are key here.
Yeah.
Schneppat highlights the importance of these things called variational quantum algorithms or VQAs. And these are particularly interesting because they combine the power of classical and quantum computing.
Oh, so it's a hybrid approach?
The hybrid approach, exactly.
What makes those so important for these quantum perceptrons?
They're particularly well suited for training these quantum perceptrons to solve these complex problems.
Okay.
One specific algorithm he discusses is the quantum approximate optimization algorithm, or QAOA.
QAOA.
And this is particularly effective for tackling really, really intricate decision-making problems.
Okay.
Helping us find the best solution among, a vast number of possibilities.
Okay, so we've got these powerful quantum perceptrons running on these really sophisticated algorithms.
Yeah.
They can handle these massive data sets,
right,
these really complex problems. But what does this actually mean for the average person?
That's a great question.
What are the real world implications of this?
That's the question that we'll delve into in the final part of our deep dive into Yorgo Schneppet's work.
Okay, sounds good.
We'll explore how this technology could potentially impact our lives in some really profound ways.
All right, can't wait. Okay, so we've looked at how these quantum perceptrons work. We've talked about some potential applications.
Right.
But I want to kind of zoom out now.
Yeah.
Talk about the bigger picture.
Sure.
What does Yorgo Schneppet, what does he see as the ultimate potential of all this?
Well, Schneppet believes that quantum perceptrons, they're really going to be a driving force in shaping the next generation of AI.
Okay.
Pushing beyond the boundaries of what's possible with classical computing.
He paints a very, very compelling picture in this paper.
He does.
It's almost like science fiction.
Yeah.
What are some of the specific advancements that he sees happening?
So one vision he lays out is a world where real-time processing of these massive data sets becomes commonplace.
Yep.
So, imagine self-driving cars navigating these complex urban environments.
Okay.
But with incredible safety and efficiency.
Right.
Or financial systems that can react to market fluctuations with lightning fast speed and accuracy.
Yeah, those are some pretty profound implications there.
Absolutely. And that's really just the beginning.
Okay.
Schneppet also sees the potential for significantly more powerful reinforcement learning systems.
Okay, remind me what those are again.
Sure. So these are AI agents that essentially learn through trial and error. Okay. They're constantly adapting and improving their strategies.
Okay.
So, imagine robots that are capable of learning these intricate tasks in real world environments, or AI systems that can manage entire power grids,
Wow.
Optimizing energy distribution and consumption on the fly.
So it's like giving these AI systems a level of intuition and adaptability that we usually associate with humans.
Absolutely. That's a great way to put it.
Okay.
And perhaps the most intriguing aspect of Schneppet's vision is the potential for entirely new AI paradigms to emerge.
Yeah.
He suggests that quantum perceptrons could lead to AI systems that operate on principles that we haven't even thought of yet.
It's like opening a door to a whole new dimension of AI.
Yeah, it's exciting stuff.
So Schneppet also talks about kind of the broader societal impact of this.
He does, yeah.
This technology.
He emphasizes the potential for accelerated scientific discoveries. Imagine quantum perceptrons assisting scientists in unraveling the mysteries of the universe.
Okay, yeah.
From simulating those complex molecular interactions to modeling the behavior of black holes.
So it's like giving these scientists
a
whole new
set of tools.
Way to see the universe.
Powerful new lens.
What other societal implications does he talk about?
Well, he also envisions applications in personalized medicine, where quantum perceptrons could analyze an individual's genetic makeup, their medical history, to tailor treatments and therapies with unprecedented precision.
And then, of course, there's the potential for more efficient resource management.
Of course, yeah.
Which is obviously becoming, more and more crucial.
Absolutely.
In a world facing climate change and all that.
Exactly. And Schneppet believes that these quantum perceptrons could help us optimize everything from agriculture and water distribution to energy production and consumption, really paving the way for a more sustainable and equitable future.
So it sounds like Schneppet's vision for these quantum perceptrons. It's not like some distant futuristic fantasy. It feels like a roadmap. to a future that's actually closer than we think.
It does. It feels very tangible. And while there are definitely challenges ahead, the potential benefits are simply too significant to ignore.
Yeah. It's really an invitation to imagine a world that's transformed by this power of quantum enhanced AI. A world where complex problems that we're facing right now become solvable.
Yeah.
Where scientific discoveries accelerate,
Yeah.
where our lives become healthier and more efficient and more sustainable.
And it's happening now. It's not some far off thing.
So as we wrap up our deep dive here into Schneevett's work, it's clear that the quantum revolution it's upon us. So it's a very, very exciting time to be alive.
It is.
And to witness all this evolution unfolding.
Absolutely.
So thanks for joining us on this journey.
Yes, thank you.
Into the world of quantum perceptrons.
It's been a pleasure.